where Group 12 and our group's topic is machine learning model for diabetes prediction. There are 5 members in our group, and the following is the division of level among the members. This is our catalog. We will discuss this in the following section. Diabetes is a prevalent chronic disease with high risk of morbidity, disability, and mortality. Early prediction is critical to prevent complications and reduce healthcare costs. Our group developed an accurate machine learning model to predict diabetes using 2022 BRFSS data, including 326 variables and over 445,000 recorders, to provide a comprehensive understanding of health behaviors and risk factors. Our main focus is on healthcare providers and public health departments. The people who will use this model include doctors, hospital managers, and public health workers. This model can help in a few key ways. For example, it can help find people who are at high risk of getting diabetes early, so they can get help sooner.
Hello, I'm WEIQI. I will talk about the next 3 parts. Despite the continuous process of medical research, the early diagnosis rate of diabetes is still low. So we wanted to develop a machine learning model that can integrate multi-dimensional health and behavioral information to achieve more accurate and earlier diabetes risk prediction, provide personalized risk assignment and intervention for different groups and suggestions. So there are 3 main objectives of our project using the BRFSS 2022 dataset to identify the most significant behavioral and health factors, to model the relationship between these factors and diabetes diagnosis, and to evaluate the performance of different predictive models and select the most accurate and interpretable approach for clinic use. Our project focuses on the healthcare domain, specifically diabetes prediction. And the reason why we chose this topic is that the diabetes prediction model has great public health and economic value. We hope this project can help us to find behavioral and social risk factors that traditional clinic models can't capture and provide strong support for precise prevention.
Okay, let's continue. My name is Zhang Li, and today I'd like to share some key findings from recent literature on diabetes risk modeling and machine learning advancements based on studies from 2022 to 2024. So the first one is a risk assignment model based on BRFSS, as noted by ZHANG et al. It mainly to develop a risk scoring system. And the next is analysis of social determinants, as noted by Lopez Garcia et al. It mainly to analyze the impact of housing instability, food insecurity, and medical accessibility. The third one is research on behavioral risk factors, as noted by Smith et al. It mainly to analyze the relationship between sleep partners and diabetes risk. So the last one is methodological innovation, as noted by Wilson et al. It mainly to combine BRFSS data with clinical data. So we can see next slide. This slide is about the evolution of machine learning methods. We can see a clear evolution in methods. So the first is the logistic regression. It is high interpretability but poor nonlinear pattern capture. The second one is random forest. It is robust to high dimensionality but prone to overfitting. The next is deep learning. It is automatic feature extraction but requires massive datasets. The last is gradient boosting. It is state-of-the-art accuracy but computationally intensive. So in summary, the field is moving towards more integrated. Yeah, that's all. My part is over. Thank you.
Hi, I am Wei-Guan. So today I would like to present about the first two steps of options, which is obtains and scope of data. Our team used BRF SS 2022 dataset as our primary data source. In this dataset, it contains 326 variables and 445,132 rows of records. And the size of dataset is roughly 398 MB. This dataset is created by CDC, which is a government agency with a creation method of service protocols. We obtain the dataset from CDC's official website and import the dataset into a Python environment for data preprocessing. Initially, we start with feature selections which generate only certain important features. Our team decided to select 26 of features out of 336 features. After that, we try to label the target variables according to the features of WD4. We label our target variables as 0, 1, and none. Next, we handle the missing value based on the missing rate. For those features with very high missing rate, we will just draw it. As for moderate and low missing rate, we apply data imputations to fill the data with medians or more. Then we deal with outlier detections through the interquartile range. For those outliers, we will distance to the lower bounds or upper bounds values. Moreover, we attempt to do one-hot encoding in order to convert categorical data into a numerical format which is more suitable for machine learning algorithms. Lastly, we do the data standardizations to standardize our data. That's all for my part, and I will pass to WEILIN for the next part. Thank you.
Hey everyone, my name is WEILIN, and I will mainly introduce the content of data exploration. Univariate analysis. Figure 1 is a pie chart which shows the probability of having diabetes. In this dataset of 440,000 records, 13.7% of people have diabetes. We also analyze individual variables to understand their distribution characteristics, such as sleep time, sex, race, income, educational level, general health. Primary analysis. We analyze the relationship between each characteristic and diabetes, including age, BMI, educational level, and general health. Multivariate analysis. We explore the complex relationships between multi-variables. Preliminary analysis of feature importance. We use statistical methods to evaluate the importance of each feature for diabetes prediction, and then we brought the top 20 most important features as 4 key findings. We also summarize key findings from the exploratory analysis. Ethical considerations are mainly introduced from 3 aspects, and the data sets we use meet the above requirements. There are 4 aspects of social impact. They are healthcare improvement, public health impact, economic benefits, and knowledge advancement. Here are all the references. Thank you for watching this video.